Hi friends, welcome to my YouTube channel SK. So guys, today we'll start to learn Hadoop big data concept. So let's come one by one. So first is what is Hadoop? So Hadoop is an open source framework that allows to store and process big data in distributed environment across cluster of computer using simple programming method. So Hadoop, we can say it's a open source framework. It allows to run, store and process the big data. So main and if we'll come to next our question like what is big data? So big data it means really a big data. It is a collection of large data sets that cannot be processed using traditional computing techniques. So the normally actually we are using this big data concept for storing and processing the data. And Hadoop is one of the framework that allow to store and process the data. Okay, and big data it is used because it is used for large data set that we cannot be processed with current traditional computing techniques. Like if you will compare normal SQL and big data, so in SQL you can run normal query like select star from table name, but it will take some time for fetching some data. It will take time if the record is large. So the big data it avoid that disadvantages, and it will handle the large data set. And it is a big data. It's processed with three V's actually. So what is three V's now? Volume, velocity, and variety. So volume in the sense high amount of data. So big data is can run with a high amount of data, and velocity is like speed of data and processing fast. So we'll get some is more speed in big data as compared to our normal traditional database, and also here processing is very fast. About variety, it is able to handle structured, unstructured, and semi-structured types of data. So actually, normally SQL it will handle only structured type of data. But let's suppose we have unstructured data types. So for that, we can go with big data concept. So this is the first our basic definition like what is big data and Hadoop. So normally Hadoop it is open source that used for store and process the data. Next come to third question, HDFS. So HDFS is nothing but Hadoop distributed file system. So it is actually used for data storage system used by Hadoop application. So in Hadoop, we are using HDFS for storing purpose, and for processing the data we are using Hive concept. Next question is how to start Hadoop. So for Hadoop, actually we need to perform some steps to start Hadoop in our system. So first, the command line you need to run like Hadoop name node hyphen format. So this command it will always set name node first whenever we start Hadoop. And second command you need to run start hyphen all.sh. So restart dash all dot sh. So this command it will start the Hadoop. And after that you need to run jps command. So jps actually it will show all the 5 nodes. And fourth command is open web UI using Firefox. So it will and we can start name node, job tracker, and task tracker. So this job tracker, task tracker, name node, this concept we'll see in later video. But first just make sure कि if we need to start any Hadoop application, so you need to run all these 4 commands. Means main is 3 commands like Hadoop name node format, then start hyphen all.sh, and then jps. This command you need to use for start the Hadoop, and after that you need to go to browser file system to see the name node and web UI information. Then next is Hadoop command. So main Hadoop command is like we need to, let's suppose in local file in local system we have one file, and I need to store that particular file to HDFS. HDFS is nothing but Hadoop distributed file system. So for that we need to run the command like Hadoop fs, then hyphen copy from local, and here we need to provide the source and destination path here. Let's take this simple example, Hadoop fs copy from local. So this is the my local path. Means let's suppose in my local PC, but this particular path I have this employee.csv input file, and I need to just load this file to this HDFS. So I will provide that HDFS path here. So this particular file it will load the data at this particular path. Okay, so this is the step. If we will do this step, then we can load the data from our local system to the Hadoop system. And after that we have some basic commands like how to delete a directory, that hadoop fs -rmr underscore user. Then how to create a directory in hdfs, so we can use make directory -mk directory. And how to delete a file, so we can use -rm, and we can provide that particular file name, so it will delete the file. And hadoop fs this will delete the particular file. And hadoop file system, it contain how to check by command, so for that we can use hadoop fs -ls, so it will show the total list of files. Okay, now next is hadoop 1.0 architecture. So guys, how it's work, I will tell with some basic example, so it will more understandable to you. Okay, let's consider you have 100 MB file. Okay, and name is like emp.csv. Now in that we have some record like id and name, and id is like 1 2 3 4, and up to 100 we have total ids. Okay, so now let's consider we have this typology. Okay, so first actually any operation in any read write operation, whenever we to perform in for hadoop, so first always it will contact to name node. Okay, if we want to perform any read write operation, first we need to contact to name node. And here guys, actually name node, what it will do, it will first assign a block to each data. Means let's suppose we have this input file, so it will take the data in a block format. Means this is the this means let's suppose this is one block one block, second block, so and so on. So and by default the block size is 64 MB only. Okay, 64 MB by default size it has. So let's suppose you have 100 MB file, and by default size is only 64 MB. So what it will do, let's suppose this is my input file, so here up to 64. After that we have like 65 and 66 and so on, right? Okay, so let's consider up to this 64 records, the data will means the size is complete with 64 MB, like means up to this we have 64 MB data, and by next data like from 65 to 100, this is the data from after that 64 MB. Okay, so up to my file consider 64 MB data, and after that it is consume around 100 MB. Okay, so for up to 64 MB it will give this means it will provide a block ID to each block. So it will give like a block ID name is block ID 1 up to 64 MB, and for next record it will provide again block ID means ID name, and it will assign a next block ID to the next block. Okay, so if let's suppose we have 100 MB file, so means it need to define with two blocks here. In block 1 it will consume first 64 MB, and next is for another data remaining data. Okay, so it will assign two block ID. So main purpose of name node, it's used for storage management. Okay, it is used for storage management, and any read write operation first it will contact to name node, and name node it will divide the data in number of blocks up to 64 MB first blocks, after that second blocks to third blocks and so on. Okay, if let's suppose we have 200 MB file, then it will divide by 64, and let's suppose we for 200 we need 4 blocks, so it will divide into the 4 blocks. And it also has providing replication policy. So what is replication policy? Replication policy means by default factor is 3. Replication factor is by default 3. So one is original and other two is a copy of that particular data. Okay. So means let's suppose this is the my one of the block. Okay, block I have. So replication process means what it means. Ki, it will first store this original data set, and also it makes two copy of this particular data set. Means let's suppose if we corrupt this data, anything mishappening, so that time it can get the data again by using this two copy of data. So we already will have two copy file also. Okay, so this is the replication policy in name node. Now come to data node. What is data node? So by data node, it is used for store the data. Means let's suppose we have this block ID stored the this is the data, this is the data. So all this data is stored on data node. So this is used for storage the data, and it send the block report to name node. Means whatever this block information like how much space it consume and what is data type and all this information. So all information about block it always send to the name node. Okay, so main concept main first two we have like name node and data node. So name node, the use of name node is for storage management, and also it provides the replication policy and factor is by default factor is 3. So always it keep a copy of one original and two copy of data. And data node actually it stores the data in means data node is used for store the data, and also it will send all this block information to the name node. Means whether this block is currently working means correctly working or not. So all this information it will send to the name node. Now next we have job tracker. There are total 5 JPS means 5 daemons are running, and the third one is job tracker. So already we see this two, like first is name node, data node, and this third one is a job tracker. Okay, so here total 5 daemons are running. First is name node and data node. So here also you can see this particular information like main purpose is storage management. If one data node fail, then it will choose the next, so it will use for storage purpose. Any operation it will first always contact to name node, and then it will divide this file into blocks, and it will assign the block ID, and then it will perform the replication policy. Means one original copy and two is the duplicate. So how it works actually: first replica on same node, second is same rake and internal rake. How it works actually I will tell you guys. Let's suppose we have one, this is my our cluster. Let's consider, okay, let's consider this is my cluster, and inside that I have 3 rakes. One, two, three. So let's suppose this is my cluster, and inside we have number of rakes. Like I can give some text. Okay, this is the my rake. Okay, so let's suppose we have total 3 rakes are there, and inside rake we have number of blocks. We can say node. So in one rake, let's suppose I have one node, two node, and three node. Here also I have, let's suppose, one node and two node, three, four node. Let's suppose we have four node. Here we have some two nodes are there. Okay, so these internal blocks are we can call it as a node where data is running. Actually our job is running here. Okay, and this outside block we can call it as a rake, or inside this we can say this is our internal rake. Okay, so how this replication policy is present: let's suppose on this particular node. Okay, so this is my 3 nodes are there. So let's suppose my that particular block it currently it's residing into this particular node here. So then my block is currently running at this particular node. So one original copy present at this particular node, and second copy where it will put on same node after that same rake, and like next one is internal rake. Same rake, internal rake in the sense inside on this another node, means we have second or third node. So here on any node it will make a one duplicate copy, and next copy internal rake. Means let's suppose this is one rake, this is second rake. So in next and rake it will put that third copy. So my original data, let's suppose my original data set it currently present on this particular node. It will store the data. Okay, so this is the replication policy, and after that we have data node that store the data, and it send block report to name node. And also let's suppose status of data node is like, let's suppose specific node fail, then how it will know. So it has one concept like heartbeat. So by using its heartbeat, which has by default interval is 3 seconds only. So within 3 seconds it will understand whether it if any nodes is fail or not. So that status of data node it also sent to the name node. What it means, like let's suppose they currently the data node is working, means this data node is running, but let's suppose due to some condition this is failed, so I have failed or corrupt. So this information it will means it will get this information by using its heartbeat, and then it will send this report to the name node. Then what name node it will do, name node it will assign, means it will choose next node. Means let's suppose this node is failed, then what it will do, it will assign the same workflow to the next node. Then this is corrupt, then it will use this node. And let's suppose this is also corrupt, then it will goes to third one. This is also corrupt, then it will goes to next fourth one. So it can create n number of nodes here. So there is no limit to create the nodes, so it will create n number of nodes. So this is the nominal and data node. After that we have job tracker and task tracker, guys. So what is the use of job tracker? Job tracker it used for schedule the job and track the assigned job to the task tracker. The main purpose of the job tracker is only that it is schedule the jobs, and it always track the assigned jobs to the task tracker. And then what is task tracker? So task tracker it's like nothing but we can say it always track the task and report status to the job tracker again. And what is task slot here? One unit of memory and CPU, means that total memory and the CPU. This information we can call as a, this is the task slot. Okay. So normally this concept is only this we can say like a task tracker. It always track the task and send report to the job tracker, and job tracker it will schedule all the jobs and assign jobs to the task tracker. One more concept we have here, secondary name node. So secondary name node it actually it will help to bake name node by using fs image and edit log. So means let's suppose due to some condition our primary name node is failed. So in that condition it the secondary name node it will help to get back primary name node. So that is used for secondary name node. Okay. So these are the total 5 daemons that's running in backend: name node, data node, then job tracker, task tracker, and secondary name node. So this total are 5 daemons. It's running in behind. Okay, so this is our Hadoop basic architecture. And now let's come to next point. What is the drawback of Hadoop 1.0 architecture? So drawback it's like let's suppose here we have name node is single point only, but let's suppose in some condition the name node will fail. So actually second name node what it will do, it will just try, it will help to bake name node. Okay, but it not acts as a primary name node. So it takes some downtime, and in this downtime period we can't do any read write operation. So whole cluster will be down for some time. So this is the biggest disadvantage in Hadoop 1.0 architecture. So for avoid that one, they introduced Hadoop 2.0 architecture. And in Hadoop 2.0 architecture, they introduced some new name node like active name node, primary name node, and standby name node. Primary name node that we currently using in Hadoop 1.0 architecture. So here they used one new concept called as standby name node. So what is standby name node? Actually, if primary name node is fail, then this standby name node it will automatic comes as a failure, means it will come it will use as a primary name node, and it will automatically failure means it will come as a automatically failure concept. Okay, means in such condition let's suppose our primary name node is fail, then second this standby name node will act as a primary name node. But in Hadoop 1.0 architecture we can means this secondary name node it not acts as a primary name node, it just only help to bake name node. So in 2 point architecture we get this new concept. So this is the main difference. Okay, so this is the difference, like cluster is most important because we store all the data metadata. So if it is down due to some unplanned event, then such a machine crash, so the whole Hadoop cluster will be down. So for handle this situation it comes under 2.0. Now what is core component of Hadoop application? So we have some core component, means for data access we are using Pig and Hive. For data storage, we have HBase, and data integration component like we have Flume, Scoop. So there are multiple. So Scoop actually for relational database we are using, and Flume is used for non-relational database. Then data management and monitoring component like Ambari, Uji, Zookeeper we can use. Data we have some data serialization component, and data intelligence component also we have like Apache Moto and Drill. So these are the some core component that we have in Hadoop. Okay. Now next is like MapReduce job run fetches. So actually, means Hadoop 1.0 architecture, it is using a MapReduce job. Okay, and it is MR. This MR it's nothing but a MapReduce. So actually, it's running in 6 phases. Means when we are running any job, so how it runs in backend that we can see today in this point. So it's actually running in total 6 pages. So total 6 pages are there. Like first is input, split. Then we have map, shuffle sort, reducer, and output. Okay. So how it works actually, I will tell you. So for that, let's come to this one. Let's take new one. Okay. Let's suppose this is my input file we have. Okay. And after that we have two blocks or split we can say. And then we have map. Then we have shuffle sort. And then we have reducer. And finally we have output. Okay, so let's consider these are total 6 pages. One is input, this is split, map, shuffle sort, reducer, and my output. Okay, so whenever we are getting the data in input format, means let's suppose we have up to 1 2 3 4 5 6, we have let's suppose we have total 100 records are there. Okay, let me keep here. Okay, so up to 1 to 100. So for that actually Hadoop it's use only 64 MB data size, block size, right? So let's suppose this is the my 64 MB data, and another next is my another 64 MB data. Okay, so now you know ki Hadoop means first actually it will store the data in block format, right? So now what is split here? We are using after input we are using split. So the difference in between block and split, I will tell you guys what is difference between block and split. So let's suppose we have this file up to 100 records, right? So let's suppose here we have 1 2 64 and 100 here. Okay, okay. So let's consider this is my input file. Okay, we have 1 1 2 3 4. So there are some records and we have some salary number. So now what is blocks? So block means let's suppose up to this we have 64 MB data, and this next after this 4 records we have another means after that 64 MB we have some records. So that will come under next block, right? So up to this we have one block. But let's suppose up to this 3 number means my ID is 3 and salary is 30. So let's consider if ID is 3 up to this one only my this means the 64 MB data is completed. So what it will do means it will complete up to this one, and this salary number this will comes under next block because it already consume up to 64 MB data here only, right? So after that this salary for this particular ID it come under next block. So this is actually not a good way to run any MapReduce job. Okay, because in one block I have only ID and another block I have my salary number. Okay, so it will happen in blocks only. But what is split now? So let's suppose now this is my two blocks, one block and two block. In my one block I have 1 2 3 10 20 30, and in second block I have 4 and 40 because here up to 60 it consume already 64 MB data, right? So let's suppose this 30 it will not come in one block because the size is already it consume already this 64 MB data size, right? So what split it will do, it will append this particular record means the 30 salary, it will append this record in first block. Where it will append, you will see like this it already consumes 64 MB, then where it will save this data. So it will save this data in its temporary memory. So this only this 30 number it will save this particular data in its the temporary memory of block 1. So after appending the data in temporary block, it is called as a split. Block and split both are same, but only difference is like this broken chunk means we miss this. This is the broken chunk, we can say, right? So append, it will append this broken chunk into the temporary memory of first block. So it will just append this particular record into temporary memory. So the after that we can call this is a split. Okay. Before appending this one, we can say this is a block, but after that we can call it as a split. So this is the only difference between split and block.